Hello everybody, hope you're all doing well during the lockdown and all keeping safe and looking after everybody at home. For our Forces 1 unit, this is lesson number 5 and it's called Describing Motion, and there are 3 objectives today. The first one is I can explain the difference between distance and displacement. The second one is I can work out displacement, and the third one, I can use this horrible looking equation that says V equals S divided by T. So think about your journey into college before lockdown. So perhaps you walk to college, perhaps you cycle, perhaps you get a lift. When do you stop? When do you travel the fastest? And what causes you to change speed? So have a think about those answers. And we're going to go through some of these later on in our presentation. But you should have some answers ready to think about and see how they compare with my ones. So let's find Tesco Express. Okay, you can see Froome, Sport and Fitness, it's in green, and some of you who know the map really well will know exactly where Tesco Express is. So let's have a look. Okay, so it's over to the right a little bit, and it's in blue with the shopping trolley over on the far right hand side. So there it is, found it, and here is one journey that you could take from Tesco to Froome College. So perhaps you've picked up something to eat on the way to college, or perhaps you've got yourself some lunch. But here's one journey that you could take. So we're just going to follow the footprints down Stonebridge Drive and then turn right at the roundabout, past the Sport and Fitness Centre, and then up into the car park. So that's one possible journey, probably the quickest journey that I can see that could be walked. So what we want to do is measure the distance from Tesco Express to Froome College. And one way you can do this is using a piece of string. So what we can do is lay the string on the route. So we know where the footprints are. So we're just going to trace that with our piece of string. So my red line on the map represents where the piece of string would go. So just angle it like so, all the way up to Froome College. See it a little bit clearer now. So what we want to do is pull that string nice and tight, and we're going to measure the length of it with a ruler. So there's my ruler there, and it says 25 centimetres. Now of course the distance between Tesco's and Froome College is definitely not 25 centimetres. If it was, oh my goodness, how easy would it be getting to school each morning? So 25 centimetres we know. All maps have a key, and this particular map says that 1 centimetre represents 15 metres. So if our line, our piece of string, our journey is 25 centimetres and every centimetre is 15 metres, then all we've got to do is multiply 25 by 15 to get our full distance. And so 25 centimetres times 15 metres gives us 375 metres. So if you were to measure the distance between Tesco's, down Stonebridge Drive, past the leisure centre to college, you'd measure it as 375 metres. Nice and easy that. Who would have known it would be so easy with a piece of string, a ruler and a key? So our distance travelled is 375 metres. Now I put the word distance in big capital letters because our first objective says what's the difference between distance and displacement. They're not necessarily the same. Well, they're not the same thing. So distance here is 375 metres. So there, the red line represents the piece of string. That's the journey that we've just done. So to measure displacement, all we need to know is where we start and where we end. We are not concerned with the journey in the middle bit. So there's our start. A nice big circle there with start there. You can see where we started. And there's the end all the way over where the college is, the left of the car park. And we're going to use a ruler, and remember it's between start and end. So we literally draw a line between start and end, a nice straight line. It's got to be a straight line. Doesn't matter if we go through the fields, it doesn't matter. It's just between the start and the end. Put our ruler on, and my ruler there says 14 centimetres. Now remember our key says each centimetre is 15 metres. So 14 centimetres times 15 metres gives us a displacement of 210 metres. So we can see quite quickly that distance and displacement are not the same thing. Distance is the journey travelled, so all the way down the red line. Okay, it goes down a bit and then across and down a bit more, then up past the leisure centre. But displacement is it's a distance, if you like, between the start and the end. It shows you how you've displaced. But we're going to need an angle as well. So what we're going to do is use a protractor to work this out. Now again, like always with physics, it looks tricky to begin with, but I promise you it isn't. So there's our blue line that we had for our displacement. This is just the straight line from start to end. So we're going to put our protractor on the start point, and you'll see that the 0 degrees goes north. It goes upwards. So what you could do is look on the map and see where north is. And on my map, this is where north is. Okay, it's going straight upwards. And you need to be careful which circle of numbers you look at. So I'm going to look on the inside numbers for this, not the outside numbers. So the inside numbers, 0 degrees is going upwards. And then we go around to 180, so follow it around 10, 20, 30, 40, all the way around to 180, 190, 200, all the way around to 360. So once we've got our 0 degrees, we put a little dot where we are on 0 degrees and we follow it round clockwise. That means we have to go to the right. So we follow it all the way around until we hit the blue line. And you can see it goes all the way around to 280 degrees. What I've not done is measured where that little red line is there. I didn't measure that inside bit there, because that would mean I would be going anti-clockwise, and that's wrong. We don't do that. We always have to go clockwise. So you measure the angle, you go up to the 0, follow north to 0, and follow it like the clock hands. It goes clockwise all the way around to the blue line, so 280 degrees. So what we could do now, we could say that the displacement was 210 metres. That was the length of our blue line using the key, at an angle of 280 degrees. And that angle actually gives us a bearing, which is a direction. So distance is a scalar. That was the red line that we worked out a minute ago with the string, and it just told us a number. Displacement is a vector. It has the magnitude, 210 metres, but it also has that direction, 280 degrees. So that's how you know which one's a scalar and which one's a vector. So this time we're going to use Frome College's 400 metre track, and you're going to have a go at answering this one for me. So there's the track there. I'm sure you've run around this many times before. And you're going to run all the way round just once. And what I want to know is, what's your distance and what's your displacement? So the blue dot is where you start. What's your distance? What's your displacement? And this would be the journey that you would go all the way around the 400 metre track. So if you need to pause the video now whilst you think about what the distance is and what the displacement is, by all means, just give it a pause now so that you have time to think about it. Okay, let's look at the answer then. So the distance is how far we've gone. Okay, that's what we've actually done. And it's a 400 metre track. We've only gone around once, so our distance is all the way around 400 metres. So if you said 400 metres, really, really well done. Displacement is actually 0 metres. Now remember, displacement was the distance between where you start and where you end. But you start and end at exactly the same point. So there is no difference between where you start and end. So your displacement is 0 metres. And there's no angle. There's no angle to calculate because you started and ended at the same point. So distance is 400 metres. Displacement is 0 metres. Well done if you got that second one. That was a really, really tricky question. So now it's going to be your turn to have a go. Here's a map. You're more than welcome to just put that up on the screen and then pause the video, and then you can get a piece of string or something, a piece of cotton or something like that, and put it on the screen and use it, or you can print it off and stick it in your book and use it that way. So what I want you to do is to measure your distance and your displacement from your home to Frome College. If your home's not on the map, then just choose another point. Perhaps you can use a furniture den, for example, or Mollett and Co. Okay, so think about where your journey would be if you went from that point, if you can't find your home. So the map I've given to you, you might need some string or cotton, scissors, ruler and calculator. The calculator would definitely make your life easier in making your calculations. So once you've done this, you're going to have to email it to your teacher at the end of all your work from today's lesson. So don't forget to do this task and email it to your teacher. So if you want to, you can just pause the video now so that you've got this task in front of you. Okay, so let's move on then. So now you're able to see your journey or a journey on the map. Think about the starter question I asked you at the beginning. When do you travel at different speeds? Well, human beings and everything actually, I can't think of very many things, don't travel at a constant speed. If we walked around the exact same speed everywhere we went, that would be quite crazy. There's always stuff in the way. There's always things to speed us up, and there's always things to kind of slow us down. So can you think of any? So pause the video and see if you can think of obstacles that slow us down or speed us up. Okay, so some ideas that I came up with. Perhaps there's traffic lights. This doesn't matter if you're walking to school, if you're cycling to school, or you're getting a lift or a bus into school, something like that. There's always traffic lights that are going to slow us down on our journey. Perhaps it starts to rain, so the weather could affect it, the speed of our journey, so we end up running to college, or perhaps we hide under a bus shelter to protect us from the rain. That's going to slow us down. Or perhaps there's lots and lots of people in the way. This is congestion. That's what that means. It's lots and lots of people in the way. And of course, that's going to slow us down. Perhaps you thought of a few others, but they're the three that I came up with. So lots of things can slow us down or speed us up. And here are three speeds that you need to remember off by heart for your GCSE. Now, this is the average person walks at 1.5 meters per second, runs at 3.0 meters per second, and cycles at 6.0 meters per second. And the easiest way to remember this is that it doubles each time. So 1.5 doubled is 3, doubled is 6. So that's my nifty little way of remembering how fast somebody walks, runs, or cycles. So maybe you stroll like the GIF at the top. Maybe you run like the one in the middle. And I don't think the guy on the bottom is actually cycling, is he? That's quite funny. But of course, this is going to depend on your age, your fitness level, the distance travelled, and the type of terrain. So if you had to go uphill, perhaps your walking speed might slow down a little bit. And if you're downhill, perhaps your cycling speed would really increase. So these are average people walk, run and cycle speeds, but you do need to write about the blue bit. You do need to write that it depends on people's age, fitness level, how far you have to go, and the type of terrain that you're moving on. So here's that equation that's going to help us answer our third objective. Now, in maths and in science, you would have been taught speed is distance divided by time. And that's perfectly fine. I would like you to write down average speed is total distance divided by total time. And what I've done, I've colour-coded the words to the letters so that you're able to see what's what. Now, a lot of people put S for speed, D for distance, and T for time. And technically, that's not quite right. V is the letter for speed because V stands for velocity, and that's the vector quantity rather than using speed. And the speed and velocity kind of get interchanged all the time. Even as human beings, we quite often use the word speed pretty much all the time. We don't really use the word velocity. You know, how fast is that aeroplane going? Oh, it has a velocity of such and such. We don't talk like that. We usually use the word speed. But technically, we should, if we know the direction, we can see where it's going, we should use the word velocity. But we don't. So the letter V is the letter we use for average speed. And it's going to throw you around a little bit. But you just need to get your head around this. Distance or total distance is S. This is crazy. The way I remember this is distance is an S. So I hope that will help you remembering it. D is used for something else, and S is the letter we're going to use for total distance. Try not to use D. Try to remember it is an S. In year 10 and year 11, you're going to be learning about something called SUVAT. S, U, V, A, and T. So there are two other letters here other than V, S, and T. And you do need to get your head around using the correct letters for each term. Time is nice and easy. That one's just T, and that one's always T. That one never changes. They've kept that one as it is. So we could say then the average speed V is total distance S divided by total time T. And if I've taught you, I'm quite lazy. I'm not going to write out average speed equals total distance divided by time. I'll use V equals S over T. It's much easier to write. And once you get the hang of what the letters mean, then this will make your life a lot easier. Speed has the unit meters per second, or m/s. Please don't ever write MPS. That's not the correct way to write it. You either write meters per second, or like me, you write m/s. So here's a practical that we would normally do in class, but you can actually do this at home if you want. You might have a book that you can turn into a ramp, or a piece of wood out in the garage. You might have a ruler, or you should have at least a 30cm ruler, maybe a couple you can put together, and you could have a stopwatch. Perhaps you could use your mobile phone. And what you could do, you could work out the average speed of a car going down a ramp. So just using the equipment here, even if you're not going to do this practical, which is perfectly fine, don't have to do this. Okay, how could you measure the average speed of the car? What would you do? So we've got the equation in the orange box. Should have just written it down. Using just that equipment there, how could you measure the average speed of the car? Well, one way is to measure the distance of the ramp divided by the time it takes for the car to go all the way down the ramp. That's the way that I would do it. So the front of the car would be 0 centimeters, and then I'd measure from the front of the car all the way to the end of the ramp. I'd press the stopwatch at the same time as letting go of the car, let the car run, and when it got to the bottom, I would press stop on the stopwatch. And then I would know how long it took to travel that distance from the front of the car to the end of the ramp. And then I would know the average speed. So this is what a table of results would look like. And on the left-hand side, it says height of ramp. So what you would do, you would make that ramp higher and higher and higher. Therefore, it would be steeper and steeper and steeper. So if you want to do this, you're more than welcome to. This is the table of results that you can fill in and then put into your book. And in the red box, even if you don't do this practical, I think this is one of those things where it's a bit like common sense. I think you could figure out the answer to this. If you have the ramp higher, what happens to the speed of the car? Does it go down faster or does it go down slower? Well, if it's steeper, of course, the car is going to travel faster. And if the ramp is really low, it doesn't have much of an incline, then it's going to take longer. It's going to be slower to move to the end of the ramp. So the steeper the ramp, the fastest the average speed of the car goes. Okay, so there you go. You should have found out that the steeper the ramp, the higher the average speed of the trolley. And you should be able to figure that one out. So speed versus velocity. We're going to come back to this again because it is important that we do wrap our heads around this. So you've worked out the average speed of the trolley. If not, let's say it's 5 meters per second. Let's say that's really, really fast. So speed is a scalar. which means it doesn't have direction. It's just a magnitude. And velocity is a vector, and it has magnitude and direction. So my way of remembering speed, velocity, what's a scalar, what's a vector, is looking at the first letters. So it sounds a bit silly, but I say speed is a scalar, and velocity is a vector. So I use a little bit of alliteration. The first letters kind of help you out. So if you get an exam question that says name a scalar, well, you already know the first letter, S, so you can think of speed. And if it says velocity, is it a scalar or a vector? Well, velocity, you know that's a vector. Like I said, it sounds silly with the alliteration, but it's one way of helping you remember which one's which. So see if you can figure out this problem I'm going to pose to you now. So a car is going to travel round a roundabout at a constant speed of 10 meters per second. However, its velocity is always changing. Why is that? So a car is going round a roundabout at a constant, that means it's not changing. It goes the same speed, 10 meters per second. However, its velocity is always changing. Why is that? Just give you a couple of seconds to think. Okay, this is one of the trickiest questions that comes up in exam papers. Velocity is a vector. That means it has magnitude and direction. If either of those things change, then velocity changes too. So if the amount, the magnitude, if that number changes or the direction changes, velocity changes too. And you can see as you go round and roundabout, your direction is constantly changing. First you're going like upwards, then you're going over to the right, then you're going downwards, then you're going over to the left. You're going round and round and round. You're not going in a straight line, same direction. Your direction is always changing. And because of that, your velocity is always changing. So it doesn't matter always about the speed. You've got to think about the direction as well when you're talking about vector quantities like velocity. Really, really, really well done if you manage to figure that out. Not many students do. That's a real tricky question. So here are some quick questions that you can have a go at. What I'm going to do, I'm going to put down the answers. So I want you to concentrate on your method. So this is Dilys Price. She's the world's oldest solo parachutist. Pretty cool, eh? Crazy Nan. She's 86 and she's from Cardiff. It's only about an hour away from us. And if she falls 4,200 meters in a minute, show that her average speed is 70 meters per second. So using the equation that you wrote down a minute ago, average speed is average distance or total distance divided by total time. V equals S over T. Show that her average speed was 70 meters per second. So if you need to pause the video, you're more than welcome to. So because V equals S divided by T, speed equals distance divided by time, that's how most people would say it. The distance is 4,200 and you need to divide it by the amount of seconds in 1 minute. So don't worry if that one tripped you up. It won't do once you get the hang of it. So 4,200 divided by 60 gives you 70 meters per second. So in your books, you should have 4,200 divided by 60 equals 70 meters per second. Right, so now we know distance has to be in meters and time always has to be in seconds. So meters and seconds are what we always need. Let's have a go at number 2 and see if you can figure this one out. So Harold Edgerton, he's known as Papa Flash. He's been making loads and loads of photographs for many years of these like high speed objects. So here we've got a bullet flying through an apple and he gets the photo right at the moment when things happen. So very interesting. If you look at Google Papa Flash, you'll see lots of different photos he's done. I think they look pretty cool. So this bullet travels at a speed of 800 meters per second and it passes through a 10 centimeter balloon. Work out how long the bullet takes to travel through it. So the answer here is 0.000125 seconds. So you've got speed, you've got v, you've got distance. Can you work out time? So if you need to pause the video and see if you can solve that question to get that red answer, by all means, just pause the video now. Okay then, so we've got the speed, 800 meters per second. The distance needs to be converted because 10 centimeters isn't right. That's actually 0.1 meters. So remember, everything's to be converted to meters. And 10 centimeters is only a tenth of a meter, so 0.1 meters. So we're going to use our V equals S divided by T equation, and time is distance divided by speed. So it's distance divided by speed, S divided by V. So you should have 0.1 divided by 800 as your workings. 0.1 meters divided by 800 meters per second. And that will give you that answer there. Right, have a go at this one now. This is a Porsche spider. It's one of my favourite insects. It's kind of crazy. It has all these eyeballs and it's able to predict the future. It's worth watching one of those David Attenborough videos on YouTube about the Porsche spider. It's kind of creepy. And the way it's able to kill other spiders is amazing. So this Porsche spider jumps with a speed of 0.4 meters per second. So there's our speed. If the jump takes 0.3 seconds, calculate how far it can jump. So what we want is distance. We need to calculate distance. Now the distance is 0.12 meters. So what I want you to do, you've got the speed, you've got time, you need to work out the distance. Are you able to get a method together to get to that answer? So if you need to pause the video now and have a go at this last question, by all means do so. So to work out distance, we need to use average speed times time. So we need to do 0.4 meters per second times 0.3 seconds. And then that will come to 0.12 meters. So 0.4 times 0.3. Well done if you managed to work that one out. So instead of our usual tasks at the end, you're going to do some egg questions for me this time. So usually in my classroom, I would hand out lots and lots of eggs and each egg would have a question inside. And of course, during lockdown, I'm unable to do this. So I'm going to show you lots of questions all at the same time and you can answer as many questions as you like. Now the red questions are all worth 1 point because they're nice and straightforward. Yellow 2 points and so on until you get up to the gold questions. They're worth 10 points each and they're really tricky. And there's a cheat sheet that's able to help you remember some of the points we've made today. So at the end of each lesson so far, I've been asking you to make things like a postcard, what I call postcard physics, or a cheat sheet or something like that. And this is what I would imagine one to look like. So I've replicated this one 3 times like I would in lesson to make it easier to print it and then I can just chop them all up. So the cheat sheet shows you all the different speeds, prefixes, that just shows you how many meters are in a millimeter, a centimeter, a kilometer, etc. Remembering how to work out time, pi times d to work out circumference of a circle, and then some conversions. So if it was me making one of those postcards for this lesson, this is what I would do. The important thing is, at the top of it, I've put a box with the V equals S over T equation and then how to rearrange it. So you might need to use this. So if you want to print screen this, and then you can use it with the questions that are going to come up on the next slide. So you might want to just pause the video, print screen this cheat sheet because you might need it for the questions come up in a moment. Right then, so once you've print screen this, saved it to one side, let's go through some questions. So there are tons of questions here. So here's the first 15. So you can answer as many of these as you want. So 1, 2, 3, 4, 5 are worth 1 point, 6, 7, 8, 9, 10 and 2 points, 11, 12, 13, 14, 15, 3 points, and so on and so on. So if you are feeling like this has been quite a tricky lesson so far, and you want to pause the video here and have a go at some of these questions here, by all means pause the video and have a go at some of these questions. However, if you're feeling a little bit more confident, you want something that's a little bit trickier because you're understanding the lesson, then I'm just going to flick to the next slide. Here it is. And these questions are a lot trickier. And if you think, yeah, I've totally got this, I don't need to pause the video here, I want the hardest questions possible, then I'm just going to go to the next slide now. Here they are. These are the toughest questions that I can think of to ask you about this. So hopefully you've paused the video at one moment here. There are 33 questions in total. You don't need to answer them all, of course. Just answer a few. Each one is worth points, and we'll go through all the answers to all the questions in just a moment. So pause the video or just rewind a little bit if you need to go back to the questions. Right, here are all the answers then. So question 1, 2, 3, 4, 5 is, as I said, all worth 1 point each. So what I've done, I've given you the method, the answer, and the unit for everything. And then you can go all the way up to the 10-point questions, up to question 33. As you can see how you've done. So add up all your points and see how many points you've got all together. And then what I'd like you to do is to total them all up, and then you can email them to your teacher, all the work you've done today and how many points you've got all together as well. As always, if you found today's lesson really, really tricky, don't worry. It's your first time you've done something like this. It is hard. It is really, really difficult work. Just email your teacher and say that you're struggling a little bit and you need some support. And then perhaps your teacher can do some live videos to help you out with this. If you want to email me, you want me to do a live session with you, I've got a whiteboard in my study, so I'm able to go through some of these calculations for you as well. Just drop me an email, dwarrington@freehamcollege.org, and I'm able to do some live sessions with you, no problem. All right, guys, take care, and I'll see you next week. Take care.